Good morning, everyone. Are you guys awake? Like, I know it's a little bit early, but I could get a little bit better than a good morning. I know we're talking about build systems and it's not exciting. Thank you. Talking about build systems is not exciting. It's not something that anyone has to want to deal with, but they're necessary. And when they work really well, you're really excited. And when they work really poorly, you're really sad. So unfortunately, it's a necessary evil. And I'm here to tell you about how Epic uses Horde and how maybe it makes sense for you to use it too. So in my presentation today, I'm going to cover what is Horde, why we use Horde, some of the Epic specific optimizations that we use to make it easier to maintain Horde, some metrics about like what Horde does for us, and then we can take some questions at the end. So the most important question is, what is Horde? And it's kind of a hard question to answer. Even if I ask the team that makes it, they might not all give the same answer, because Horde has so many different things that it can do for you and your team. So the thing that most people use it for is it's a CI/CD system. It'll build all your Unreal code, and it'll do it pretty good. It also has a build health system. It also has a distributed build system. It also has device management. It has automated test executors, and probably more things in the future. So the question is, why should you use Horde instead of whatever else you're using right now? A lot of people use Jenkins or TeamCity or whatever they've used with other engines. Why should you use Horde? Really, the biggest thing is it's made for Unreal, by Unreal. All of the things in Horde are specifically made to work basically out of the box with Unreal. And it supports all of the things that you would expect from Unreal. It is also it's in production here at Epic, so we use it to build all of these products you can see here. It's used for Unreal Engine, for Fortnite, for Rocket League, for MetaHuman, for Fab, all of the stores. Everything gets built in Horde. This will support any project UE 5.0 or later. You can get away with other projects as long as you have the automation tool and build graph, but I don't recommend it. So one of the biggest things, I think, coming from a lot of other build systems and coming to Horde is that Horde is very Perforce-centric, which is very important to a lot of game teams. Horde allows you to use more than one Perforce server, which makes it easier for you as a company to have more stability in your build system. Like if one of your servers goes down, it'll just choose a different one and continue without any problems. It also supports using multiple distinct different servers. So like Epic has one Perforce server that has Fortnite and Unreal in it, and there's another Perforce server that we have that has Psionics stuff, so Rocket League and things like that, and you can pull from both of those different servers independently. It also has a really neat system for caching files and reusing workspaces, so you don't have to worry about your Perforce server getting polluted by a bunch of workspaces made by built machines across like a bunch of different edges, for example. It also has a lot of optimizations to minimize the amount of information that it requests, because as we all know, Perforce is not the greatest tool ever, and it can be pretty slow. So we've tried to minimize the amount of information that we request from Perforce in order to sync and get our build machines ready. So build health is important, obviously. You all know this. That's why you're here. How does Horde help you? So Horde has a lot of things that you can use to streamline your process, make it easier to uncover when there are defects in your code or your content. Here we have, these are what the Fortnite like regular CI looks like. We have a bunch of different badges that align to specific steps that can tell us the health of certain platforms or certain content things. So this is Fortnite meme. It's going to be read a lot. That's just something we've understood and we're going to be okay with. But you can see like all of these different badges align to a different client, so you can get an idea of like where a breakage is and try to fix it. Eventually, you want to get to this. This is a Fortnite release branch. We're all green all the time, hopefully. This screenshot, we're mostly green. But you can see, you know, there's an editor test that failed, and it was fixed on the next run because we, you know, surfaced this information to whoever, and they were able to fix it. So build health is a big deal at Epic. We have so many developers all over the world working on so many different things at the same time. Horde really makes it easier for us to manage this because we don't need an army of people yelling at different developers or artists or whatever to get their stuff together and fix it. Here you can see this is a bunch of issues that Horde has discovered and opened, and it's pretty smart about not opening duplicate ones, although it's not foolproof. If it sees the same warning or the same error across multiple different jobs on the same step, it'll all put them in one defect, and you can work from there. It also has Slack integration. Epic is a completely remote company, so we do a lot of our communication through Slack and not through just like getting up and talking to a person at a desk. This makes it really easy as a build engineer to help people find out why their build is broken. A lot of times people will commit something bad, it'll break somebody else's build, and they're like, I don't know why it doesn't work. Here I can point them to the Slack thread like, hey, this person broke it, this is where they're working on it. You'll see when it's fixed, and then you can run your build. So the automation that we have with Slack will also dump a link to the build. It will open up the issue. It will allow you to assign yourself to the issue if you think that it's you. And it will give you a small snippet of what it thinks the error is, which can be pretty easy to quickly identify the culprit. In some cases, or I should say in a lot of cases, if there are specific issues that you're using structured logging for to point out what is the issue, Horde can automatically tag a person on Slack and let them know, hey, I think that your change here broke this. We found an issue in this file and it's in your Perforce check-in. Take a look and see if this is what what change broke it. Here it also lets you update. You can see at the bottom here, you can make an issue in Jira if it's a long-term problem, or you can also mark it as fixed in a specific change list. Horde will automatically close this defect if your next run of that change list or higher fixes that issue. If it is not fixed, it will reopen the issue and then tag that person and be like, hey, that didn't work. So like I said, Horde has a lot of ways to track issues in Horde itself. And if you need longer term tracking of issues, you can link it to a Jira and track it that way. Some people really like to do that. Some people don't really like to do that because it's not really important that like, oh, you missed a semicolon in a file. Like you don't need a Jira for that. So it helps us it allows us to minimize the amount of people that we have trying to stomp this stuff out because it's pretty much automated from the get-go. Now, it doesn't catch every single error like that. Sometimes people have to go in and check what's actually happening. In fact, the build team often has to go and look and investigate when there's like systemic issues with like machines, like if they run out of space or they can't connect to a service or something like that. So like obviously those issues are not going to be fixed by developers, but the vast majority of developer issues are not something that the build team has to deal with as a result. So the question everyone asks is, why is the build slow? And not what we can do to make the build faster. So UBA is something that I hope a lot of people have heard about, and if you haven't, I would recommend looking more into it. This is not a UBA talk because I would need more than the amount of time that I have here to talk about it, but you'll have to trust me. UBA is great. It's very fast. You use Horde as an orchestrator, so even if you don't want to use the CI/CD system and you're working in an office and you want to make your compiles faster, you can set up a Horde instance in your office, and you can use UBA on all of your developer machines to help compile on other developer machines. With Horde specifically, we take advantage of AWS Spot instances. We use Linux and Wine as UBA agents to minimize costs. And year over year, our costs keep going down despite making more and more builds. So it has really been one of the key cost savers for Horde and for Epic. Just some other things like the UBA agents in AWS are extremely smart. They will use compression to send files, so you minimize the amount of egress and ingress costs you have from transporting data. And also, it will use instances in the same AWS region as a proxy and send all the files to one and then have them distributed to the rest of the UBA agents and then send everything back. This is mostly just, like I said, to minimize costs and to improve efficiency. So the next question is, I have all these devices. How do I manage them? It's a problem for a lot of different companies that I've worked for, and I feel like Horde has one of the better solutions to this issue. So device management is pretty easy on Horde. You can connect your consoles or phones or whatever you're using to test to Horde directly via an agent. And it allows you to do remote checkouts. So here we have a system where you can check out a dev kit if you need it to do something. It's just like a library book. When you're done, you check it back in and someone else can check it out. It's all automated, so no one has to like go in and specifically tell, hey, this person needs to check it in, or is this available, or whatever. Everything is taken care of there. It also allows you to manage dev kits that maybe have an issue. You can disable them, or if they need to be updated, like the wrong firmware version, you can do that too. This also has a nice feature where it tells you when the dev kit will be available again for however long that person has checked it out for. So Horde also has some metrics that you can see here about what automated tests are running on those dev kits and when they're the busiest. So if you're having an issue where your dev kits are saturated for a short period of time, you can find a way to move your tests and spread them out over a longer period so that you're not trying to do every single test at 1 a.m. Eastern, because then you'll just have all your stuff be busy for a couple of hours and then idle for the rest. Here there's more things that you can see for metrics. So these are automation pool. This is not ones that you can check out. Here it has some kind of health check things where it's going to basically see, sometimes a dev kit will fail very often or it'll fail less often. You can kind of get an idea there. Sometimes it's the test, sometimes it's the kits themselves, but you never actually know. But here you can see that Horde thinks that this specific, this is PS4, has a problem because it failed too many times over the last 3 days. And here you can go in and see where it's failing, what jobs it's failing on, and what the failure rate is, and maybe have someone go investigate that dev kit and see if it's causing issues. Obviously, you don't want false positives, in your testing, because that defeats the purpose of it. This is a more in-depth view of how your dev kits are being used. So we use the dev kits across multiple different products and multiple different streams. And from this view, you can see where they're being used the most, what time of day, if you make it smaller. You can also see like what kind of dev kits you're using and stuff like that. So you can see if you're like, oh, my PS5 dev kits are never available, why is that? Who's using them all? And here you can kind of get a bird's eye view of what's happening there. This is just another representation of the pool of dev kits and how they're being used. So here you can see, I've spread it out to show you like what the Fortnite release branch was using. It had 81.5 hours of the 1,734 hours. It's a lot of time. But here you can see, maybe some teams are using them too much, or some teams don't have enough, and you can kind of fine tune your expectations from here. So the question is, how do we manage all of this? There's a lot of things going on here. And the Epic build team is pretty small compared to a lot of other build teams that I've seen at other companies. We're only 5 people. So part of it is the way that Horde is configured. There are 3 major configurations that are used day to day. And they have different sharing with the game team themselves. So the project JSON is per project. The stream JSON is per stream in the project. And then the build graph itself is in the project themselves, in that stream. So the first important thing is the project JSON. This is owned by the build team. We're the only ones that do any editing to this, because this will impact how much resourcing is used. So basically, when Fortnite is ready to make a new release stream, they let us know. We will go add it to the project JSON. and enable it in Horde so that they can start using it. What this does is it also makes it so that people can't enable too many streams without killing off old ones, which could cause problems because you'll run out of hard drive space eventually. So this is some snippets of what the project JSON looks like. This also controls what it looks like in Horde itself. It has some abilities to sort streams into different columns to make it easier for people to find what they're looking for. So this is what our Fortnite project page looks like. So all of the different columns, general releases, cinematics, performance, other, those are all configured in the project JSON itself. So the next thing is the stream JSON. So the stream JSON is the most important thing for each individual stream. So for each new release stream, we'll create a new stream JSON to match that release. This is owned by the project themselves. We will help them to massage it to a good place, but generally speaking, they do the updates there, and we don't touch it if we don't need to. So this is an example of one of the templates that's in the stream JSON. Templating is how Horde basically makes jobs. It doesn't really have an understanding of what a job is. That doesn't really exist. So this template tells you what all of the settings are for the incremental job. The target is in the build graph XML, and all of these settings are set when it runs. You can do additional things like set the schedule. You can add more parameters to show in the Horde UI itself, but this job runs automatically, so there's no additional parameters. So what that creates is this that we've seen already. This page, the incremental page, is only has certain builds, only has incremental builds. The different other tabs will have other builds types in them, and those you can also define in the stream JSON. And then the stream JSON will also show up here. This is the project page again. When you add a new stream, it'll show it in this page. So this is an easy way to tell whether or not you actually set it up correctly. And the last thing is the build graph. The build graph is the heart of what's actually going on. This is individually versioned in the stream itself. So if you retire a stream for your product and then need to bring it back later, whatever your stream JSON is at the time and your build graph at the time should still work together. So you don't have to worry about versioning that or upgrading it to a newer version. Previously, I had showed you snippets, but like the Fortnite build graph XML is nonsense. So here, this is what it looks like. So eventually that gets us to this, which is the Fortnite incremental CI job itself. This is not all of the steps. This is just what I could fit in the screenshot. Here you can see all the different steps and how long they take. And as you add more steps to it, it will show them further down. One of the real keys to build graph is the dependency system, which you can use to move files from machines that are better at a certain job and move them to a machine that's better at a different job. So for example, we don't do cooking and compiling on the same machine. It doesn't make any sense. For us, it's more efficient to move the files from the compiler to the cooker when it's done. It allows us to scale out and do more faster. So here you can see how we accomplish that. These timelines are different steps in our build process, and the more parallel steps we can do at the same time, the faster the build will get done, obviously. And here you can see there are certain steps that are required that will block other steps until it's ready. So the gray line is the how much time it's waiting for either a machine or for it to set up. The blue line is the, actually the blue line is the setup, I'm sorry. The gray line is waiting for a machine. And then the green line is when they're actually doing work. So here you can see the whole job took about an hour, but if you did it sequentially instead of parallel, it would have taken probably 2 or 3 hours. So one of the things we do with Horde is we share machines across streams. There are some upsides and downsides to this. One of the upsides is it saves hard drive space because the difference between Fortnite 34 and Fortnite 3410 is pretty minimal. Most of the files are the same. But as you go further and further away from the root, it gets the differences get bigger. And sometimes, even though it shouldn't be that big, Fortnite puts Darth Vader AI in Fortnite, and then all of a sudden there's like 1,000 extra files that don't exist before. So one of the things it can do is it can save hard drive space, but sometimes that's not true. Sometimes it can save startup and shutdown time. If you can have a machine that can run in multiple different streams, you don't have to turn off that machine and turn on a different machine and wait for that. It also reduces the amount of maintenance we need to do because there's just not as many machines. Not every branch gets its own specific machine. So some of the cons, like I said, are the startup time can also be increased. If you're going from Fortnite 34 to Fortnite 35, there's going to be a significant amount of difference, and switching over to that stream can take a really long time. It's also a problem sometimes if people start a lot of jobs at the same time. It's easy to over provision the machine, the pool by just having too many people starting jobs. And sometimes some of them are more important than others, and they'll get their own pool. So that brings me to what do we do? What do we do with Horde? What are we talking about in terms of like scale, right? Like Fortnite is one of the biggest games in the world. What does that look like in Horde? So the Perforce is very big, very, very big. These numbers I took in March are wrong. It's more than this. Whatever this number is, it's more than this now because we just always more. But there's a lot of challenges that come with a 6 million file Perforce stream. That's 2.2 terabytes that your team hopefully will not have to deal with, but Horde can deal with. And it's, I think, important to like look at this and be like, yeah, if it can do this, it can definitely do whatever you're doing, right? So here's another look. This is the number of agents on average that Horde has running at a time. So there's 1,600 AWS cloud agents and about 400 on-prem agents, and that does not include UBA agents, which scale a lot depending on what we're doing. It's between 400 and 500 on an average day. So about 2,500 agents are connected to Horde at any one time. So the way that Horde looks at work is in terms of leases. So you lease a machine to do a job, or to do a step, excuse me, and then return it to the pool. Horde does tons and tons of leases, which end up in 133,000 releases every day, which get recorded in our database, and you can look at later if you need to, but it's a lot of work. And what that really translates into like completed jobs is a little hard to like figure out because we don't really have an idea of what a job is. Jobs don't exist in Horde as you would expect, but it's about 2,200 jobs per day on average across all of the stuff at Epic, which is tons and tons and tons of work. So Horde is definitely suited to do basically everything you need it to do, and I'm hoping that after this, you can give it a chance and give it a try. Thanks everyone for coming out, and if you have any questions, there's a microphone here, or you can just scream it out to me, I guess, whatever makes you happier.